Okay, great. Well, thank you everyone for coming. I appreciate it. My name is Jeff Baxter. I work for NetApp Incorporated. We are one of the leading data management companies and storage providers in the U.S. and worldwide. So the topic for today's session for the next, I think it's 3 hours, 45 minutes. I wanted to see how many people bolted immediately, or at least went for Mountain Dew or something. The topic for the next 45 minutes for this presentation is around you don't invent electricity by improving candles. It's actually a quote from one of our customers, CERN, one of our very largest customers dealing with a lot of these big data challenges, just immense amount of data, really with the recognition, and we'll get into this during the presentation, that some things about big data are very familiar to those of us that have dealt with data for the last couple decades. Other things are sort of a quantum shift, so to speak, which is funny when you talk about CERN. But it really is the idea that when you reach certain orders of magnitude, certain structures break down, right? You just can't get a better and better candle. You've got to skip to something else entirely different, right? So what I'll be doing for the rest of this talk is kind of talking about a little bit about big data in general and sort of how we visualize it at NetApp as we help our customers deal with the challenge. And then some specifics around a new category of big data around object storage and how we're dealing with these large distributed content repositories that are really challenging conventional notions about what it means to store, manage, and access data. So that's a little bit with what's on tap for the next 45 minutes. My background, just so you're aware, I manage our consulting systems engineering team as well as being one of our principal architects for our public sector business worldwide. So what that means in a nutshell is I've been with NetApp now going on about 6 years. Had a history behind that of being in storage consulting, and then before that I ran a data center. I actually ran storage and a bunch of enterprise servers for George Washington University back in Washington, D.C. So not quite the same sort of public sector, but very similar sort of challenges, especially when it comes around big data. And now for NetApp, I act as a principal architect. I work out of our corporate headquarters in Sunnyvale, California, just down the road, an hour or 3 hours, depending upon traffic, and work there on how we're managing architectures going into the future to deal with big data. So, a little bit about why big data, and this may be remedial for people at a big data conference. I fully acknowledge that, but what we've seen and why we really, quite frankly, over the last decade, but really over the last 5 years, have kind of honed in on big data as the next frontier of data science, is really this idea. First of all, there's data growth everywhere, and I'll talk a little bit more about it, but it's not just the traditional sort of 10% growth or 20% growth or even 50% year-over-year growth. It's these whole new categories of applications that introduce orders of magnitude growth, right? Things that we're just not familiar with dealing in any sort of scale, right? I think for a large part with traditional, what we would call, traditional data, we're used to the idea of maybe hard drives even keep pace with the data growth, right? 5 years ago, they were 250 gig drives, then 500 gig drives, then 1 terabyte, 4 terabyte. We see roadmaps out to 6 terabyte and beyond, right? And seems to kind of keep pace with that rate of traditional data growth, right? And there almost has been a sort of steady state equation there. Not quite, but close enough for government work. But when you get to big data and you're talking orders of magnitude growth, right? The traditional approaches of just add a few more hard drives or just wait till the hard drives get bigger next year just aren't scaling. So the traditional approaches aren't scaling. The traditional infrastructure is impractical, and the ongoing operational complexity of building out more and more silos or building out more and more storage systems to deal with this growth. When you have customers now who are literally having conversations about exabytes, right? That's a whole different conversation and doesn't just consist of, well, let me just throw a couple thousand storage systems out there. Even if you could do it from a budget perspective, and even if you could do it from a space, power, cooling perspective, the operational complexity becomes immense, right? It just starts to break down under scale. And finally, once you have all that data, the time to value is just way too long, right? The time to extract value from that data is way too long. We have an example at NetApp where our auto support database, where customers will send in their data from their storage systems, it was taking us to do basic business intelligence queries to try and do trending and see if some particular subsystem was causing more problems than it should, right? All those sort of things you'd expect us to want to be able to do was taking days to run queries. And sometimes we wouldn't even know what queries we wanted to run against that database, right? So that was one of NetApp's first experiments with big data. That actually turned into a Hadoop environment where we put a lot of that auto support data on, and we were able to do customized queries against that data, things we hadn't even thought of for that day, and get responses back in a matter of minutes or hours, whereas before it might have taken days and days to do that sort of data. So that's just an example of how big data is really addressing a challenge of the time to information, and it's also addressing an opportunity, right? If we can all find ways to take this mountain of largely unstructured data and find structure within it, that derives huge business value or huge value to our customers and to our clients. So we really feel, and this is something that's been building now, that we're kind of at this inflection point in the mid-decade, right? We're hitting this point where information is like a wave, right? It's either something that you get on top of your surfboard. I'm not speaking from personal experience. You get on top of your it'd be bad. You don't. You get on top of your surfboard and you ride that wave, right? And it becomes a propellant to business and drives you forward. Or quite frankly, it breaks over you and drowns you, right? I mean, we're literally at a point where data is not something that you can tread water in because it's gently increasing every so often, right? I'm going on vacation to Hawaii in 2 weeks. This is in 2 months. Wow, okay, I really need that vacation. But it's not something where you can just sit there and tread water, right? You've got to figure out a way, if you're in this environment where you're dealing with big data growth, you've got to figure out a way that you can get ahead of it, right? That you can use it to drive business forward. And we're really seeing, not every business, I'm not going to be, cataclysmic and say every business is going to face this challenge, but a lot of businesses, a lot of agencies are going to face this challenge where the differentiator is going to be the ones that manage to latch onto this and use it to move forward are going to gain significant competitive advantage over the ones who don't, right? In the public sector, the people who are able to figure out new ways to take data that's coming in, to find new uses for it, are going to be the ones that can provide better services, that can extract better data for the citizens, and can provide overall better intelligence about what's going on in the state, right? In the commercial sector, it's even more Darwinian, right? Coke or Pepsi, whoever figures out buying habits better is going to have a substantial advantage in terms of being able to move things forward. So a lot of things are driving this data growth, right? There's really this convergence of technology disruptors, right? So this, by the way, is the buzzword bingo slide. If any of you had cloud, please check that off. No. I always joke if you get through a presentation these days where you don't hear cloud, flash, big data, or mobile, then someone wasn't following the marketing slides. But, kid you not. But, so big data, big data is driven by a lot of different sources, but we really are starting to see things like social media, people who are doing, it's almost crazy, people are trying to do analytics on Twitter, like literally all of Twitter, right? I mean, that's a big data challenge, right? Separating the selfies from the actual useful data, right? That's a big data challenge. Mobile, more and more, I mean, everyone now is an endpoint, right? Everyone has an IP address sitting in their pocket. That's a huge differentiator. And then we talk about, how many of you have heard of this concept of Internet of Things? Have you heard that term before, right? I'm seeing some nodding heads. And, it goes back to the old joke about my fridge having an IP address, right? I don't know why my fridge is going to need an IP address, but for the last 10 years, the consumer electronics groups have been saying, eventually your fridge is going to need an IP address, and you're going to run out of milk, and it's going to order more milk from Amazon, which seems like a horrible idea, but on so many levels, but at least now it'll be delivered via private drone, so that'll work out okay. But this Internet of Things is really driving just a huge amount of machine data, right? So if you abstract the human being even from generating the data, it's just going to be a flood of information coming in from every IP addressable device out there. I mean, that in the end is probably, for people who follow networking, is going to be finally what breaks the dam on IPv6, right? Because there's just, you're going to need your own, class B network in your own house at this point, right? So that's what's going to finally break the dam on IPv6 and other things. All of that combined, all of that becomes big data, right? So the interesting thing about big data, and this is kind of how Gartner looks at a lot of things. They call it a hype cycle, but in big data, we're really only, a lot of people think we're kind of still heading up towards this peak of inflated expectations, right? We estimate that the size of the digital universe right now, and this is, I can't believe I'm starting to use this word, but the size of the digital universe right now is a couple zettabytes worth of information. And by 2020, it should be up to about 40 zettabytes. Okay, now a zettabyte is 1,000 exabytes, which is 1,000 petabytes, right? So, I mean, it's a literal mountain of data. I did just for fun, I did a graphic, another presentation showing that if you took one of our disk shelves and just stacked them up on top of each other, 8 zettabytes, which is what we figure it'll be at in a couple of years from now, 8 zettabytes would reach about to mid-Earth orbit. So way past the International Space Station, right? Just shoot right by that. I was hoping it would hit the moon. It's a better graphic, but that'll probably be around 2025 when it would hit the moon. So that's just an immense mountain of data that makes up our digital universe. And we're adding, huge amounts of data. I mean, 30 billion pieces of new content to Facebook per month, and only half of those are my wife. Okay, I'm in trouble. This is videoed, isn't it? Oh, great. 5 billion smartphones out there, and more importantly, 80% of that they estimate is this unstructured data, right? It's not sitting in any sort of database. It's not sitting in anything that has a schema or any way that's easy to organize, to filter, to sort, to drive any intelligence out of in any sort of way that we've learned over data science or computer science over the last 50 years, right? It just sits there with no structure inherent to itself other than just being there. So how do we drive data out of it? Now, the interesting thing is, Gardner now argues we're starting to fall from this sort of peak inflated expectation into this, sort of trough of disillusionment, right? Where, I'm curious, and no names or anything like that, how many of you are starting to feel like this? Like we've had this hype cycle around big data. People like me have been sitting up here saying big data, big data, big data, and everyone, yells out Hadoop, and now everyone is starting to say, okay, that's great. Now, what the heck do I actually do with it? What does it mean, right? Okay, I'm seeing some nodding heads, so that's good. This is very standard on a hype cycle, and I won't even argue that it hasn't been overhyped, right? Part of the whole process is that everyone gets excited about something new, whether it's cloud or big data or flash or anything like that, right? And we all hit this peak where it's going to solve world peace, right, and end hunger, right? Now we actually shoot back down into this trough of disillusionment where we go, this was all hype, it's not actually going to do anything, blah, blah, blah. And then, we come back out of it. So we come back out of it, back up into what they call the slope of enlightenment and the plateau of productivity, right? So the truth about where big data is going to land is somewhere in between this peak where, Hadoop was going to solve everything, or, big data was going to organize all the data in the world. And we go into a place where big data has its place within the data center. It's a structured part of how you do business, and it actually produces results. So we kind of look at big data at NetApp. We broke it down, because we're vendors, it needs to be really simple, into sort of our ABCs, right? Analytics, bandwidth, and content. Generally, if there's some inflection point between at least one, but preferably 2 or more of these, you can think of it as a big data application. So what do I mean? Well, analytics is really around the idea of how do I derive value from all that data? So you tend to start looking at distributed compute farms, right? Think of like a Hadoop farm. Think of any other sort of columnar database or anything like that where you're trying to get a very simple scale-out grid approach where you've got a balanced approach between compute and storage, right? It looks very similar almost to the HPC models that have been built up over the past several decades, if anyone's familiar with HPC, right? With Luster or anything like that, except your target is not trying to slam high bandwidth, it's to deal with large amounts of data and perform analytics across a distributed data set, right? So analytics is usually a key part of big data. Bandwidth is very interesting. Big data, because it's unstructured and because you're trying to process a lot of it, a lot of the applications, certainly not all, but the vast majority, end up with very high streaming bandwidth, right? And this is, from a storage perspective, intriguing to us because everything we've been doing really up till now, the focus has been more around IOPS, right? You always hear storage vendors talk about IOPS. So whether it's 1,000 IOPS or 10,000, or now that we're busy talking about all flash arrays, everyone runs around going, I can do 400,000 IOPS, or I can do 1 million IOPS, or, it's always the one-up game there. But we're all talking about these sort of OLTP-based workloads where everything is about, read-write mixes of 80-20 and small block sizes, right? Big data, what we found is because you tend to be dealing with objects, and a lot of them, especially when you're dealing with things like full motion video or other large artifacts, right? It tends to be more about how can I stream bandwidth, right? So my individual file may not be very small. It may actually be gigs in size or even bigger, in terabytes in size. So streaming bandwidth starts to become very important, as does dense configurations, right? So density always becomes an issue in data centers up to a certain limit, at which point it's not worth the extra couple U it would take to get denser. Big data tends to turn that heat up a little bit more, right? Where when you start talking to me about 80 petabytes or something like that worth of data, if I can squeeze a couple extra disk drives per rack unit, that actually has real-world benefits in terms of the number of floor tiles, and if maybe not even building out another data center, right? So we've seen an increased focus on density and being able to do that. And the final part is really content, and that's what I'm going to spend most of the rest of our time talking about, specifically object storage. But really what we're seeing is this demand now for boundaryless containers, right? And by boundaryless container, I don't mean, you know, come right up, I'll sell you a storage system that never ends, right? That'd be really cool. Be like a magician who keeps pulling scarves out, right? But what I mean by that is I can build a container that logically has no endpoint to it within a reasonable site, and that I can scale out and scale out and scale out and keep adding storage onto it, and that logically the method by which I store and retrieve data doesn't change, right? That's the concept of a boundaryless container. And today, sort of like table stakes for that is being able to say I can do tens of petabytes, right? And I can conceivably scale up to exabytes without necessarily having to change anything about your architecture, right? That's kind of where table stakes are today in the boundaryless container space. We found most, I hesitate to say all, but almost all customers aren't yet at a point where they need a boundaryless container of an exabyte or something like that. If you happen to be one of them, there's a couple NetApp sales. No. But for the most part, you know, being able to say, hey, we can do a container that scales out to 2 petabytes or 5 petabytes or 60 petabytes, right, has made people very happy because it provides future proofing of 5 years, 10 years, something like that. And then different access technologies, right? So different ways of accessing data when traditional file systems start to break down. And I'll cover this in a little more detail, but that's really fundamental to the idea of content, right? We're not just saying, here's a really big CIF share, or here's a really big NFS export. It's different ways of even accessing that content repository. So all of these come together are ABCs to produce what we call a big data ecosystem, right? This is the big data buzzword bingo slide, right? This is, you know, there's definitely overlap. When you look at, you know, bandwidth and then big content, you get into rich media, right? So, you know, if you're a broadcaster or media producer where you're producing thousands and thousands and thousands of hours of 1080p and soon to be 4K content, right? So you've got both problems, right? You need huge streaming bandwidth, you need a lot of data, and you also are going to have a lot of unstructured media, right? So that's where you get the overlap in the Venn diagram between the B and the C, right? All of these NoSQL things that are coming out are new SQL, right? Whether they're fully broken from structured relational databases or sort of a hybrid mix of them, those have both the content repository portions of them where they are almost certainly being deployed on an infrastructure that's managing billions of objects, but they also require the analytics portion in terms of being able to derive value now from that non-relational database, right? So this is kind of how we look at things and how things line up into this category. And so this is really internally how we use to focus our product offerings and look at big data. The one I want to focus on for the rest of the session is really object storage. And that's the idea of a fundamental shift in how we store large quantities of data. And by quantities, I generally mean large independent numbers of objects, right? So billions and billions of objects. So data today, human and machine generated file data, generally what we found across corporations represents about 80% of corporate data, right? Structured content represents, you know, maybe 15%, with the other 5%. I always love when a slide says other. It's like, wait, it's structured on, okay, semi-structured data. So you can't really delete the data. In a lot of cases, you're not legally allowed to. In other cases, the data is actually what you're performing the analytics on, right? You've got to keep it. But in a lot of cases, 97% of the data will never be touched again, right? We see cold data that's cold for decades, right? One of my favorite customers that I deal with, you ask them what their retention period is, and their retention period is the life of the Republic, right? Which, of course, my immediate response is, can you tell me what that is? Because I'd like to make some stuff. No. You know, because if I knew, I'd put gold under my mattress, right? But they literally are having these retention periods that are 70 years or life of the Republic or my ever favorite, infinite, right? Where it's never going to be touched again. And so it's just way too expensive to keep this data on traditional primary storage, right? Regardless of how cheap we try and drive down that primary storage and how many tricks we play on it, traditional, you know, no matter what you do, that primary storage is going to be within a dollars per gig order of magnitude range, right? I mean, it's going to be bounded, right? You can certainly go out to Best Buy and buy the cheapest 1 terabyte drive possible, and you can certainly go to a tier 1 storage provider and buy the most expensive dollars per gig, you know, especially flash and stuff like that. But it's all going to be bounded within a certain range. And that range just sometimes doesn't work when we start getting into this huge quantity of data, right? So we've got to think about different ways we want to handle it. So we've got this location problem, right? It's like the real estate issue, right? What are the top 3 things in real estate? Location, 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 right? So inactive data is sitting and growing on the primary storage, so it's way too expensive. On the other hand, the magical solution that's been offered to put it on the cloud, it's basically free, right, is also incredibly risky. And I'm not one of those cloud haters or something like that, right? Sometimes you see a guy from a vendor from a storage company like, oh, don't put something on the cloud. NetApp does a lot of different things with the cloud. We have partnerships with Amazon, partnerships with hundreds of cloud service providers, and we think the cloud makes perfect sense for hundreds, thousands of applications, right? Public-facing websites, data that's already public, right? All these things that go out there. There's certain data, though, that probably no one's going to want to put public or that it's going to take a long time to do, right? And unfortunately, a lot of that tends to be the data that we're talking about in these large-scale content repositories. So the data needs to be moved. It needs to be on a less costly storage tier, and it also needs to be accessible in a controlled manner from anywhere, right? For state of California, that could mean up and down, the state. For some of my other customers, it could mean literally anywhere in the world, right? Anywhere you go that has a U.S. flag, they want to be able to access the same data. This is a very common requirement I hear from some of my federal customers, for example. And it needs to be immediately accessible, always on. And in a lot of cases, it needs to be accessed by its owner over the internet, right? Whether that's a secured connection via the VPN or whether it's more public data and it just can be from any endpoint, right? We need to be able to make that data essentially location independent. So we have these challenges on traditional infrastructures, this rapid, untamed growth. We've got to perpetually retain large and growing assets, and we've got distributed users. So the needs that drives in products are we need to be able to scale products to a petabyte scale. It needs to be able to handle billions of objects. I had a customer say the T word, right? Trillions of objects. And I went, I don't know if we're even there yet, but I mean, that's starting to come up. Policy-based management so that we can actually move the data on demand, right? Human scale moving of data. I'm going to move a couple objects from one place to the other. I'm going to, for those of you who have a storage background, right, I'm going to move a LAN or a volume from this tier to this tier. Work great for traditional data. For big data, it becomes a non-human scale management problem, right? So everything needs to be driven by policy-based placement. And we need predictable location-independent access, right? So regardless of where you are, we need to have a way to have the data be local to you or at least accessible to you. So all of this is really driven what I call sort of the third way of accessing data. The 2 traditional ways are block and file, right, that I think most people are familiar with. Block is really, traditionally it's meant I have a disk drive, right, and I'm accessing the individual sectors on a disk drive. And then over the last several decades, we've done some very fancy things where we make huge storage systems that export what looks like a disk drive, a logical unit number, right, a LUN, right? And that, still has sectors, right? It still is accessed by all the traditional commands. It makes the server or the application think that there's a disk in there, even if it's spread among thousands of disks, right? That's old hat by now, right? That's block storage. And then there's file storage, right? So there's the concept of traditionally NFS or CIFS, right? I'm going to present out a file path and a file name, and you're going to store data there, right? Starting with the original Unix systems, starting with the original Windows systems, and now you have appliances that do it for you, right? So traditionally you have SAN storage that does block, and you have NAS storage that does file, right? So there's a whole new category arriving that's really called object storage. And this is not, by the way, a NetApp specific thing, right? This is a new category of storage that the whole industry is starting to embrace. And the idea is, it is fundamentally different. It's sometimes convenient to look at it as just another type of file storage, but it's fundamentally different because unlike being defined by file paths or location or name of the file, it's really defined by the metadata and tags around the object. The object doesn't, by definition, have a specific home, right? It doesn't have a home directory, it doesn't have a share, it doesn't have anything like that. It just exists within a content repository, potentially a global content repository. So how does that actually work? I like to use the parking garage versus valet example. And by that I mean when you park your car, think of your car as an artifact of data, right? If you take it to a parking garage, right, you go ahead and you put that parking garage, you put that car in a specific space within the parking garage and then hope you remember where it is. Or like me, you have to write it on the ticket, right? And you write down, okay, I'm in daily garage 1, I'm on floor 4, I'm in row N, and I'm in space 53, right? So that's my path, right? Traditionally in a file system, right? I may be in /users/jsmith/car/garage1/floor4/row N/space53.file, right? Say that 5 times fast. I need a drink. Or, if it's Windows, if it's a, share on Windows, it might be C users J Smith, right? So the file is defined by its location, right? the file is retrieved by its location, right? It's unstructured by definition. It's not sitting in a database, but the database essentially is the file system. If you compare that by definition to valet, I circled the convention center a couple times today trying to figure out where I was supposed to park, and eventually found a place behind the building. And I pulled in and realized it was one of those, leave your car with the valet type of parking garages, which always makes me nervous that they're going to absolutely wreck my 2007 Ford Fusion. Please take it. But I walk in, right, and they give me a ticket. Okay, and that ticket has a number on it. So in this case, say 317. That ticket is a unique identifier for the object, in this case, my car. The valet then takes my car away. I have no idea what he's doing with my car, right? My car is probably parked in one of these spaces over here, but he could have taken it to a garage around the corner. He could be joyriding it around Sacramento, enjoying the scenery, right? But more likely it's parked in a space. But all that I care about is when I go back there in a couple hours and hand him that ticket, that my car gets delivered to me in a certain time as defined by an SLA, right? So when I give him my ticket, hopefully my car comes back in a couple minutes, right? And it looks the way it was before. It's validated. It's secure. It matches block for block what I gave him to, right? And doesn't have large dents and missing data in the back, right? That's what object storage is about, right? It is really the concept that I don't have to know where the data is stored. I give an SLA, I give a policy, I give my data over to the object repository, and when I need it, I can call it back. So each object includes not only the user-provided data, right? I mean, obviously the biggest part of the payload is going to be the data, but it's almost like a networking packet where there's metadata or routing information about it appended to it, right? So the metadata becomes part of the object, right? So whether it's user-provided metadata and identifiers, or whether it's system-generated metadata and identifiers, as well as a fingerprint to ensure, no data corruption, to ensure resiliency of the object through transit, all of that becomes the same. And then that object in and of itself is an atomic immutable object, right? In most object environments, when you make a change to the object, because remember this is something that tends to be stored once, read infrequently, and changed almost never, right? That just becomes a new version of the object when you change it, right? So the objects become, generally in most object implementations, immutable. So there's a lot of different things you can do with this. When I say user-provided data, that doesn't necessarily have to be provided by the user. It might be provided by the application that's writing to the content repository, right? So one of the big spaces that object environments are used a lot are in medical imaging, for example. They dealt with early on this proliferation of relatively large files and millions, potentially billions of them, right? I don't know about you, but the number of imagery that gets done is just remarkable, right? Number of lab tests, different things like that. And they really need to store those for the life of the patient plus 7 years, something like that, depending upon local jurisdictions. And so that user-provided metadata provided by the application might be, this is an MRI scan. The ordering physician was Dr. Smith, right? The patient's name is this. The patient's identifier is this. It was done at the Sacramento Medical Center. The client is normally in the Livermore medical center. And all that is metadata that becomes a part of the object, right? And then we add our own system metadata around this is the time the object was ingested, here's where it was ingested, all that other information, so that it becomes fundamentally a part of the object itself, and we can act upon that data, right? So we can take that data, and if we know, for example, that my MRI was taken up here, but that I normally go to Livermore or Sunnyvale or something like that, we can make sure that that object is stored both here and down there, right, in advance. We can set up policies that act upon that data. If we know that the ordering physician was Dr. Smith, we can go ahead and put a copy at whatever server is closest to Dr. Smith in advance, right? We can store those objects in multiple different places. So an object doesn't necessarily, in an object store, doesn't have to be stored just once. In fact, most of the data protections that you're storing it 2 times, 3 times, 4 times, based upon policies set by either the system provider or the user provided metadata. So we end up with a distributed content repository. And when we say distributed content repository, it is what it says on the tin, right? It's a repository designed expressly to store these large amounts of content, and it's almost always distributed across multiple sites. Yes, you could build a one-site distributed content repository, but it tends to be an oxymoron, right? In most cases, you have multiple sites, and whether they're across the street from each other, across the state, all of them deal with multiple tenants, have multiple policies, have multiple administrators, and you have storage at multiple different sites. And in most cases, it tends to be disk storage. Some people still use tape as well for the really, really long-term archive, just based upon the policies of the individual objects. And then you can talk to that storage, and I'll talk more in detail about this, Traditionally, it's through an object interface, through a special form of HTTP called HTTP REST. But you also can talk to it through CIFS or NFS, more traditional sort of NAS protocols that we're using as sort of a gateway to move over to this new object-based paradigm. So at any given site, whether it's site 1, 2, or site N, there's a single centralized view of this content repository, right? So if I'm at site 2 and I ask for object 317, I'm going to get back object 317. Whether that site has it cached locally in memory, whether it has it cached locally in disk or stored locally in disk, or whether it has to go to the other side of the state and pull it back, it's going to appear back just as it was stored with no, oh, I'm sorry, you're not there, or you have to go to this file system, or you have to mount this server. It's all part of one large distributed content view. So NetApp has a product called Storage Grid, which is our implementation of this. And this session, by the way, is not intended as a sales pitch for that. I'm using it mostly because this lets me relate how it becomes productized, right? So excuse that for a second. You can just put whatever product name you want up there. But Storage Grid is the way we implement a distributed content repository. And let me say, just while I'm thinking of it, it's becoming an emerging space, right? Storage Grid has been around for close to 5 years, maybe longer, right? But it's still, frankly, in that sort of emerging space because the number of customers that actually need billions and billions of objects has been fairly limited until recently, right? It's just starting to pick up steam. So it's an interesting ecosystem. There's probably, I'd say 5 major players in it, something like that. I'm probably giving it a little bit disservice, maybe 10, something like that. It's certainly not nearly as big as I would consider the traditional NAS or SAN market where you have, frankly, hundreds of players and probably 10 or 20 major players there. But it's starting to pick up steam. So we've been doing Storage Grid now for about 5 years. This large content repository can store billions of data sets, dozens of petabytes, provides the predictable access to data independent of location with policy-controlled data stores at each site, and it provides this sort of intelligent data classification access. So based upon the metadata that's within each object, we can go ahead and manage it. So I'll talk a little bit about what that does. From a reliability standpoint, we can go ahead and protect against site disasters simply because the data is spread across all sites. By default, when you set up a policy, now you can kind of do the shoot yourself in the foot policy and not do this, but by default, when you set up a policy for data, it's going to always make sure there's at least 2 copies, one at each site, right? And if you have a 3 or 4 or 5 site configuration, you can say, I want to store 2 copies, 3 copies, 4 copies. So generally, say you have a 5 site, you'll say, I want to store 2 copies or 3 copies, right? And it will always make sure that the object is stored at one site and another site. And independent of anything else, it'll just kind of pick randomly and balance, right? But if you've given it additional metadata like, hey, these users are most likely to access it, it will store it over at that site, right? So it creates affinity for certain sites to each object. We also can then go ahead and guard against network disconnection, data corruption, media degradation. So if one site goes down, or if just the connection from one site to another goes down, it will automatically intelligently reroute from the local gateway nodes at that site and find any other node on the distributed content repository that still possibly has this object and pull it back. So if there's any connection from point A to any other point B that has the object, it will transparently serve it back without the end user, the end application ever knowing that the original site it was trying to do has it. In fact, one of the unique things it does is it will actually in mid-file switch to another site, right? Whether that's because the object is corrupted or because it's lost connection to that site. This isn't important if you have a 4K file or an 8K file, but if you're trying to stream a 10 terabyte video stream, right, or move 10 terabytes worth of data and 5 terabytes in, it gets stuck, right, or something crashes here. The fact that we can just continue with the rest of the slices of that object from another site means that you have this uninterrupted stream of data to the application or to the new site. We also can go ahead and as the object comes in, we automatically checksum it. You saw that in the object identifier, but we add that checksum to the back end of it, right? So every time we write or then read back an object, we check the checksum against the object to make sure it hasn't silently been corrupted, right? So almost every disk subsystem you store things on, ours, others, will also do that, but this is an additional layer of sort of logical protection that nothing has happened, bit flips, any sort of thing that can happen. I often say, it's like, any of you watch House, that show, right? Patients lie, disk drives lie. Right? Disk drives are horrible things to store data on. It's too bad they're the only thing we usually have to store data on, right? They will sit there and flip bits in the background. We have jokes every so often about cosmic rays. It's like, because theoretically a cosmic ray hits it and it bit flips, right? So we want to go ahead and as we're reading back, just in case RAID or anything else hasn't caught it, or checksumming, we want to go ahead and check it against that. We also optionally can encrypt it, right? So we can do AES encryption so that if someone gets access to the data store at one of those sites, right, they can't pull it back without access to the keys, right? And we can independently encrypt each different item as it gets stored. From an availability standpoint, we talked about this, but it provides this highly available access so that we can have this global object namespace, regardless of where you are, whether it's in Sacramento or San Diego, right? The namespace is going to look exactly the same. If the namespace is named State of California, right? That's it. Wherever you are, you get access to it. Okay? And from a scalability standpoint, we're able to scale out linearly because we built a system that doesn't have any central shared database that is the nexus or bottleneck through everything grows. In fact, it looks a little bit like this in terms of a functional diagram, right? So we have storage systems on the bottom end, and then we have this, what really is the heart of it is this location transparent distributed object store, right? So it overlays all the different storage systems and puts this object level data management on top of it. On top of that, we build a namespace. That's really the idea of how do we store the UIDs, how do we store things by metadata, and then most object ingest and retrieval is going to come through this HTTP RESTful protocol or this new standard called CDMI, and that's where we're able to do metadata tagging and querying, right? That's where I'm able to come in and say, I want UID 317, or a more interesting thing is, I want any object that was stored in Sacramento on January 20th. And it will return to me a list of every object that was stored in Sacramento on that. And from that point, I can then say, okay, now I want this object pulled back, or I want this object pulled back, right? That gives you a whole different level of, you don't necessarily have to maintain a relational database on top of this to keep track of where things are. You can let the actual content store do the work for you based upon the metadata. And finally, I did mention these NAS protocols are really a gateway. I think if everyone kind of had their way, they'd wish it wasn't there, right? And just go pure, go object interfaces, right? Unfortunately, in the real world, nothing changes overnight, right? So I'd say a large part of object databases, they tend to still be object-based, but they have these NAS gateways that sit in front of them that accept data in via SIFs and NFS, at least while legacy applications are transitioning over. So in a lot of cases, if you have a legacy application that's attached to a traditional content repository, you can object enable it through those protocols. You don't, I'll be honest, you don't get every single benefit of an object store that you would potentially want, right? You can't always tag the metadata, you can't do a lot of different things, but you can at least get the data in that content repository, and then over time we expect applications to start addressing this in a more standardized method. So from scaling out, really that gateway node, right, that gateway accepts the object, whether it's via object interfaces or via NAS interfaces. We have these sort of centralized control nodes in between that really do all the command and control in terms of keeping track of the UIDs, in terms of routing requests back and forth. And then we have the storage nodes at the bottom that actually have disk attached to them and store data. So if we want to scale out, we literally just scale out, right? So if I need to add bandwidth or throughput, I just add gateway nodes. If I need to add capacity, I just add storage nodes, right? And there's not necessarily a one-to-one, right? So if my throughput is doing fine, I just need to add storage. Just add storage node after storage node after storage node. If I have enough storage, but I really just need to increase access to it, speeds to it, I just put more gateway nodes out. And I can put more gateway nodes at a local office, for example, because each of those gateway nodes may have just its own internal memory or maybe one or two drives inside the server or the unit, and that can improve data access by just caching more locally. So finally, the nice thing about this is it's a software-based approach. NetApp does provide it as a pre-configured solution with all the components that's available from NetApp distribution partners. One of the nice things, I mentioned density. We have one of the more dense enclosures at NetApp. So this does, in 4U, does 60 drives. So you have 4 terabyte drives. So each one of those is about 240 terabytes. You stack 10 of them together, you got about 2.4 petabytes on a floor tile, on a traditional floor tile, right? So for a customer, if they need to build out a 20 petabyte distributed content repository, you can conceivably do that in 10 racks, 10 standard racks, right? I mean, just incredible density. So we then integrate that, provide all the hardware integration, do the software installation, and then you can go ahead and be standing up a content repository, quite frankly, in a matter of days, right? And that's one option. Then there's software-based options. There's other, as I mentioned, there's other vendors that do this as well. But this is kind of how we're trying to productize and move this forward in a more rack and stack, easily deployable model for customers to be able to move towards distributed content repositories in a quicker pace. The final piece of this is really something called CDMI, which is this cloud data management interface. I have no idea why it says cloud as the first word, other than that was the buzzword when they named it. But really what it's about, it's a protocol that was defined by a SNIA working group. How many of you are familiar with SNIA, by any chance? Storage Networking Industry Alliance, right? It's where all of us storage vendors, essentially, and data management vendors, all go into a room, leave the guns and knives outside, right, and actually try and work things out for everyone's benefit, right? So we work on storage protocols, different things like that. So CDMI was defined by our working group that has a lot of the names you know and love. One of our Office of the CTO, one of our lead people in the Office of the CTO actually was the co-chair and led this working group. The definition was actually written, the CDMI definition was actually written by the CTO of our storage grid group, right? So NetApp's had a pretty heavy involvement in that. CDMI is really trying to, it's, you know, the nirvana of, I want to be able to move objects from one cloud to another, to my private cloud, to a public cloud, regardless of who the vendor is behind it. Is it a pipe dream? I really desperately hope not, quite honestly, right? You often look at vendors and think, you guys really want lock-in? In this particular case, it serves everyone, especially with cloud and everything like that. If people can move data, we'd love it if you could buy you know, an object content repository from us and then exchange objects perhaps with someone you bought from a competing vendor or with insert your cloud vendor of choice, right? So CDMI defines really three key areas, right? It's a protocol and a specification where you can initiate, the client can initiate a client-to-cloud data transfer. Within the cloud can manage data, right? So it can say, I want these objects to have this SLA, this policy be protected this way, and then can also transfer data from one cloud to the other without it having to disintermediate and come back to your data center and go back out, right? I want this cloud to talk nice to this cloud and move my data. Storage Grid is one of the first. There are now several other products that support CDMI. We're hoping that over the next couple of years we'll get to critical mass, because once enough products support CDMI, this will become the interface. This will be that HTTP RESTful interface that really drives content repository, just like NFS or CIFS, as relatively standardized protocols, regardless of where they came from originally. Now they're standardized protocols. If CDMI becomes that standardized protocol, then everyone's clouds and everyone's content repositories will be able to work together. And that'll be a great result to move this forward. So, in conclusion, NetApp is really committed to this object content repository space, primarily because we have customers who are demanding that we be that way, right? Our largest customer is now over an exabyte, right? If you had told me 5 years ago that we'd have a single customer that had an exabyte worth of storage, I would probably say you were crazy, and or I would request a transfer to that account. But probably both. But you know, we have now 4 customers over 100 petabytes, single customers, multiple hundreds and hundreds of customers that are up over 10 petabytes, right? So this is, in some cases, experimental and notional for the vast majority of us, but it's real for some of our customers, right? They're really telling us we're facing these challenges now. We're drowning in this data, these billions of objects. We need some new way of looking at things. And so this third new way of doing things, from block to file now to object, is really, hopefully over the next decade, going to become a third pillar of how we store and manage data, especially big data. With that, I want to say thank you for your time and really appreciate it, and hope you enjoy the rest of the conference. Thank you. I'll be around if there's any questions. Yeah, we're time. I'll be around if there's any questions. I'll be in the room. And NetApp has a booth out there as well if you want to talk to someone from NetApp.